2. Amount of substance. 2.1. Relative atomic and molecular masses, the Avogadro constant, and the mole. The actual mass in grams of any atom or molecule is too tiny to find by weighing. Instead, the masses of atoms are compared and relative masses are used. This was done in the past by defining the relative atomic mass of hydrogen, the lightest element, as 1. The average mass of an atom for oxygen, for example, is 16 times heavier to the nearest whole number, so oxygen has a relative atomic mass of 16. Scientists now use the isotope carbon-12 as the baseline for relative atomic mass, because the mass spectrometer has allowed us to measure the masses of individual isotopes extremely accurately. 1/12 of the relative atomic mass of carbon-12 is given a value of exactly 1. The carbon-12 standard, defined below, is now accepted by all chemists throughout the world. So, the relative atomic mass, AR, is the weighted average mass of an atom of an element, taking into account its naturally occurring isotopes, relative to 1/12 the relative atomic mass of an atom of carbon-12. So, relative atomic mass, AR, equals average mass of one atom of an element divided by 1/12 mass of one atom of carbon-12. Molecules can be handled in the same way, by comparing the mass of a molecule with that of an atom of carbon-12. The relative molecular mass, MR, of a molecule is the mass of that molecule compared to 1/12 the relative atomic mass of an atom of carbon-12. So, relative molecular mass, MR, is average mass of one molecule divided by 1/12 the mass of one atom of carbon-12. You can find the relative atomic mass by adding up the relative atomic masses of all atoms present in the molecule, and you find this from the formula. Relative formula mass is the term used for ionic compounds because they don't exist as molecules. However, this has the same symbol, Mr. One atom of any element is too small to see with an optical microscope and impossible to weigh individually. So, to count atoms, chemists must weigh large numbers of them. This is how cashiers count their money in bank. Working to the nearest whole number, a helium atom, Ar equals to 4, is 4 times heavier than an atom of hydrogen. A lithium atom, Ar equals 7, is 7 times heavier than an atom of hydrogen. To get the same number of atoms in a sample of helium or lithium, as the number of atoms in 1 gram of hydrogen, you must take 4 grams of helium or 7 grams of lithium. In fact, if you weigh out the relative atomic mass of any element, this amount will also contain the same number of atoms. The same logic applies to molecules. Water, H2O, has a relative molecular mass, Mr, of 18. So, one molecule of water is 18 times heavier than one atom of hydrogen. Therefore, 18 grams of water contain the same number of molecules as there are atoms in 1 gram of hydrogen. A molecule of carbon dioxide is 44 times heavier than an atom of hydrogen. So 44 grams of carbon dioxide contain this same number of molecules. If you weigh out the relative or formula mass, Mr, of a compound in grams, you have the same number of entities. The actual number of atoms in 1 gram of hydrogen atoms is unimaginably huge. 602200000000000000000, usually written as 6.022 times 10 to the power of 23. The difference between this scale, based on H equals 1, and the scale used today based on carbon-12 is negligible for most purposes. The Avogadro constant, or Avogadro number, is the number of atoms in 12 grams of carbon-12. The amount of substance that contains 6.022 times 10 to the power of 23 particles is called a mole. The relative atomic mass of any element in grams contains 1 mole of atoms. The relative molecular mass, or relative formula mass, of a substance in grams contains 1 mole of entities. You can also have a mole of ions or electrons. It is easy to confuse moles of atoms and moles of molecules, so always give the formula when working out the mass of a mole of entities. For example, 10 moles of hydrogen could mean 10 moles of hydrogen atoms or 10 moles of hydrogen molecules, H2, which contains twice the number of atoms. Using the mole, you can also compare the numbers of different particles that take part in chemical reactions. If you want to find out how many moles are present in a particular mass of substance, you need to know the substance's formula. From the formula, you can then work out the mass of 1 mole of the substance. You use number of moles, N, equals mass, M in grams, divided by mass of 1 mole, capital M, also in grams.